One aircraft could change wide-body aviation forever. Composite wings larger than any jet ever built. Engines the size of 737 fuselages. Range to fly nonstop from Sydney to London. Here are 10 mind-blowing things you must know about Boeing's 777X. Number 1. Folding wingtips. First in commercial aviation. The Boeing 777X is the first commercial jet with folding wingtips. This represents a genuine aviation breakthrough. No other passenger aircraft in history has featured this technology. The wings extend to 71.8 meters in flight. This massive wingspan provides better aerodynamics and improved fuel efficiency. Larger wings generate more lift. They create less induced drag during cruise. The result is significantly better performance on long-haul routes. But airport gates were designed for smaller aircraft. Existing infrastructure cannot accommodate wings this large. Gates at major airports have width restrictions. Aircraft exceeding these limits cannot park at standard gates. Boeing solved this problem with folding wingtips. The wingtips fold upward on the ground. This reduces the wingspan to fit existing airport gates. Airlines can operate the 777X without requiring airport infrastructure modifications. The folding process takes about 20 seconds. Pilots monitor the operation from the cockpit. Dedicated controls manage wingtip position. The system includes safety interlocks, preventing takeoff if wingtips are not properly extended. Sensors verify wingtip position continuously. If wingtips are not locked in flight position, warning alerts activate. The aircraft cannot take off until wingtips are properly secured. This safety system represents new technology never used before on commercial airliners. Airlines get huge wings for efficiency without needing larger airport infrastructure. This makes the 777X commercially viable at airports worldwide. Without folding wingtips, the aircraft would be restricted to airports with oversized gates. Number 2. Largest composite wing ever built. The 777X introduces an all-new carbon fiber composite wing. This design was inspired by Boeing's experience with the Boeing 787 Dreamliner. The Boeing 787 proved composite wings deliver significant advantages over traditional aluminum construction. The 777X composite wing provides several key improvements. It offers a higher lift-to-drag ratio compared to metal wings. The larger wingspan increases total wing area. Additional fuel capacity is integrated into the wing structure. Composite materials weigh less than aluminum. This weight reduction improves fuel efficiency. The aircraft can carry more passengers or cargo with the same fuel burn. Alternatively, it can fly the same payload with less fuel consumption. The wing design enables more efficient long-haul flights. Lower fuel burn reduces operating costs for airlines. Better range allows nonstop service on previously impossible routes. The composite wing is central to the 777X's performance advantages. Number 3. GE9X, the world's most powerful jet engine. The 777X is powered by GE Aerospace's GE9X engines. These represent the most powerful commercial jet engines ever built. Each engine produces over 110,000 pounds of thrust. The GE9X is also the largest commercial jet engine in history. The fan diameter measures 134 inches. For perspective, that is larger than the entire fuselage diameter of a Boeing 737. The engine alone weighs approximately 18,000 pounds. The GE9X features a higher bypass ratio than previous generation engines. More air flows around the engine core rather than through it. This improves fuel efficiency while reducing noise. The engine meets stringent modern emissions standards. Advanced materials enable the GE9X's performance. The engine uses ceramic matrix composites in hot sections. These materials withstand higher temperatures than metal alloys. This allows the engine to run hotter and more efficiently. The combination delivers massive power plus improved fuel economy. Airlines get the thrust needed to lift a 426-passenger aircraft, but they also get significantly better fuel burn than older engines. This balance makes the 777X economically viable. Number 4. The largest twin-engine passenger jet ever. The 777-9 variant becomes the largest twin-engine passenger aircraft in the world. This represents a significant milestone in aviation history. Previous aircraft this large required 4 engines. The 777-9 can carry up to 426 passengers in a two-class layout. High-density configurations could seat even more. The aircraft is longer than a Boeing 747-400. It offers near jumbo jet capacity without needing 4 engines. 2 engines instead of 4 creates enormous operational advantages. Airlines save money on maintenance. Only 2 engines require servicing instead of 4. Fuel consumption is lower. Parts inventories are smaller. Crew training is simpler. The 777-9 proves modern engine technology can power very large aircraft with just 2 engines. This changes airline economics for high-capacity routes. Airlines can move massive numbers of passengers more efficiently than with older 4-engine aircraft. Number 5, ultra-long-range capability. The 777-8 variant offers extraordinary range capability. Boeing estimates the aircraft can fly approximately 8,745 nautical miles. This equals roughly 16,190 kilometers without refueling. This range enables nonstop service on previously impossible routes. Airlines can fly from Singapore to New York nonstop. Sydney to London becomes possible. Los Angeles to Melbourne requires no stops. These ultra-long routes generate premium revenue for airlines. The 777-8 achieves this range through several factors. The efficient composite wing reduces drag. The GE9X engines deliver excellent specific fuel consumption. Large fuel tanks hold enough fuel for 15-plus hour flights. The combination enables true any city to any city connectivity. Airlines operating these routes can charge premium fares. Business travelers value nonstop service highly. Avoiding connections saves time and reduces travel fatigue. The 777-8 makes these routes economically viable for the first time. Number 6, Dreamliner-inspired passenger experience. The 777X borrows many passenger features from the Boeing 787 Dreamliner. Boeing learned valuable lessons from the Boeing 787 program. Passengers clearly prefer certain comfort features. The 777X incorporates these across the cabin. Larger overhead bins provide more carry-on storage. Passengers can store bags more easily. Boarding and deplaning become faster. Bin space has long been a passenger complaint. The 777X addresses this issue. Electronically dimmable windows replace traditional window shades. Passengers can adjust window tint electronically. Flight attendants can control all windows from a central panel. The windows never have broken shades. Ambient light control improves throughout the flight. LED mood lighting, inspired by northern lights, creates calming cabin atmosphere. Different lighting scenes support different flight phases. Blue tones during cruise promote relaxation. Warmer tones during meal service. Brighter lighting before landing helps passengers wake naturally. Higher humidity and lower cabin altitude reduce passenger fatigue. The Boeing 787 introduced these features with great success. The 777X replicates them. On 15 to 18-hour flights, these comfort improvements significantly reduce jet lag and arrival fatigue. Number 7, wider cabin with 18-inch economy seats. The 777X features a wider interior cabin than previous 777 models. This allows airlines more flexibility in seat configuration. Economy seats can be 18 inches wide instead of the typical 17 to 17.5 inches. One additional inch may seem minor, but on long-haul flights, the difference is noticeable. Passengers feel less cramped, shoulder room improves, comfort increases significantly over 12-plus hour journeys. The wider cabin stems from the 777X's larger fuselage diameter. Boeing optimized the internal structure to maximize usable cabin space. Airlines can choose wider seats or add extra seats per row. Most premium carriers will likely choose passenger comfort over density. This makes the 777X more comfortable than many older long-haul aircraft. Passengers notice the difference compared to aging 777-300ER aircraft. The improved experience helps airlines compete for premium passengers. Number 8, advanced aerodynamics and laminar flow nacelles. The 777X uses laminar flow engine nacelles. These represent advanced aerodynamic technology. The nacelles cover the engines and attach them to the wings. Laminar flow means air flows smoothly over the nacelle surface. Turbulent flow creates drag and reduces efficiency. Laminar flow minimizes drag significantly. Even small drag reductions compound over thousands of flight hours. The nacelles improve airflow over engines. The This boosts overall fuel efficiency. It also reduces noise. Smoother airflow generates less turbulence and sound. Communities near airports benefit from quieter operations. These aerodynamic improvements help reduce fuel burn and operating costs. When combined with a composite wing and efficient engines, the 777X delivers approximately 10% better fuel efficiency than the 777-300ER it replaces. Number 9. Smart cockpit and wingtip monitoring system. Because of folding wings, Boeing added new cockpit technology. The wingtip control system monitors wingtip position continuously. Pilots have dedicated controls and displays for wingtip operations. The system provides alerts if wingtips are not properly positioned for takeoff or taxiing. Warning messages appear on flight displays. Visual and oral alerts get pilot attention. The system prevents takeoff if wingtips are not locked in flight position. This represents new aviation safety technology. No previous airliner needed wingtip position monitoring. Boeing developed this system specifically for the 777X. It required certification approval from aviation authorities. The cockpit also features large touchscreen displays. Boeing incorporates modern avionics inspired by the Boeing 787. However, Boeing maintains traditional physical controls alongside digital displays. This reflects Boeing's pilot authority first design philosophy. Number 10. Boeing's most tested aircraft program. The 777X has logged more test flight hours than any Boeing aircraft program during certification. This extensive testing reflects the aircraft's revolutionary technologies. Regulators require comprehensive validation of new systems. Boeing began 777X flight testing in January 2020. The program faced multiple setbacks and delays. Technical issues required design modifications. Regulatory requirements expanded following the Boeing 737 MAX crisis. The test fleet includes 5 aircraft. These aircraft have flown thousands of hours across various conditions. Testing validates performance, systems, structures, and safety. Every aspect of the aircraft undergoes rigorous evaluation. As of 2026, production aircraft are expected to fly in certification testing. Entry into service is likely around 2027. This represents a 7-year delay from original plans. The first delivery was initially scheduled for 2020. The intensive certification reflects lessons learned from the MAX crisis. The FAA maintains heightened scrutiny of Boeing programs. Every system receives exhaustive testing and documentation. This ensures the 777X meets the highest safety standards before entering passenger service. Despite delays, airlines maintain confidence in the program. Emirates has 205 aircraft on order. Qatar Airways committed to 94. Lufthansa wants 20. These orders demonstrate airline belief in the 777X's capabilities. Airlines are willing to wait for an aircraft that delivers revolutionary performance and efficiency.